Hi everyone. Today we are going to study modularity in system analysis and design. Modularity means decomposing a system into smaller components that can be coded separately. So basically the concept of modularity here means that you are dividing the entire information system into smaller components. These components are called modules, and then the coding or the programming for each component is done separately. Now, because of this modularity, the design clarity of the information system increases because the entire system is not coded as one but divided into smaller parts, and then those smaller parts are coded separately, so that it gives design clarity, which in turn results in easy implementation. When the design is clear, obviously the implementation becomes easier. So when you have design clarity, it gives you easy implementation. When implementation becomes easy, the testing also becomes easy, because instead of testing the entire long piece of code, you have to test the codes for small modules. Debugging, that means finding out errors, also becomes easier because there are smaller codes now. And the documentation and maintenance of the software product also becomes easier, because when you have to maintain one module, only that module would be maintained or debugged, and rest other modules would not be tested or maintained. So whatever error, whatever problem there is in one module, only that module will be touched, and we will not have to look into other modules. It will be easier to find out the errors also. So modularity does not simply mean chopping of the system into smaller components. Now when we say modularity, usually we think that chopping off or dividing the system into smaller components. Of course it is dividing the system into smaller components called modules, but it does not mean chopping of the system. There are certain concepts like coupling and cohesion that need to be followed while breaking a system into different modules. That means we do not just simply divide a system into modules or smaller components without any rule. There are certain rules that have to be followed while dividing the system into its modules, and the two important principles for division of a system into various modules is that it must follow coupling and cohesion, which we will study in the upcoming session. Now, what are these set of guidelines? As I said, you just cannot simply chop off the system into smaller modules without any rules or guidelines. So, what are these guidelines for good design? The first guideline is that a system should be divided into as many relatively independent modules as possible. When I say relatively independent modules, this means one module should not be dependent upon the other module. If some changes are required in one module, it should not affect the other module. Any changes done in one module should not affect the other module. Any error in one module should not bring in errors in any other module. And this process of dividing the system into large number of relatively independent modules is known as factoring. Another important guideline is that a superordinate module should not control more than 7 subordinate modules. Now, superordinate modules are those modules which are at the top. The parent module is known as the superordinate module, and the modules at the lower levels or the child modules are known as the subordinate modules. So as per the rule, no superordinate module should control more than 7 subordinate modules. But obviously there is no such fixed rule, and this can vary from system to system depending upon how large or how small the system is. The third guideline says the dependency levels between modules should be minimum. As I said in the first guideline only, that the system should be divided into relatively independent modules, as many as possible. So this is what is being repeated in the third guideline, that is, the dependency between modules should be minimum. That means when you divide the system into relatively independent modules, obviously the dependency among the modules decreases. Also, the communication between modules should be through parameters. So like in functions, you have seen how one function communicates with the other function, or how one function calls the other function by passing parameters or by passing arguments. So this is what is we are saying here, that the communication between modules, because these modules are basically nothing, what we call functions in software programming are these modules. These modules are the functions. So therefore one module should communicate with another module through parameters, by passing parameters or arguments. A module should not perform more than one function. A module should always stick to one function. Say for example, if you consider a simple C program and you have one module or one function for multiplication, then you have one function for division, then you have one function for subtraction. So this is what it says, that at any given point of time, any module should not perform more than one function, and it should stick to that particular function only. That means a module should not be doing all the tasks at the same time, otherwise then what is the point of having module? We divide the system into modules so that each module does its own independent task. But then if a module is doing more than one task, then this purpose of dividing into module is no longer served. Hence, we should stick to the fact that no module should perform more than one function. One module, one function, that is the rule. Then the fifth guideline says that modules at the lower level of the design are called by more than one superordinate modules. Modules which are at the lower level, which we call by the name of subordinate modules, can be called by one superordinate module, right? They can be more than one superordinate module who can call the module at the lower level. What does this mean? This means that multiple superordinate modules use most of the modules at the lower level. Now, lower level modules are those levels which will be performing functions for the modules at the superordinate level, right? So one module is performing one type of function, and different modules at the top may require the same module for that particular function. That means there cannot be a strict rule that only one module can call a subordinate module, or one module can call a module at the lower level. Several modules which are requiring that task to be performed at the top level or at the superordinate level can call the module at the lower level. So basically, multiple superordinate modules can use most of the modules at the lower level. So this is all about modularity in system analysis and design. In the next video, we will discuss the two basic principles, that is coupling and cohesion, which are required for modularity, and we'll be discussing coupling in the next video.